Okay, another question that involves differentiation. We've been given a cubic, we've been asked to find the gradient function, and then we've been asked to find the range of the values of x where the function itself has a negative gradient. In other words, where dy dx is less than 0. Okay, let's get the finding of the gradient function out of the way. Okay, doing it term by term, bringing the 3 down and multiplying by the invisible 1, 3x, and we reduce the 3 by 1, 2. Minus 2 comes down, multiplies by the 2 to make 4, and then the power is reduced by 1, so x to the power 1, which is just x. This is easy, negative 15. And then the last term, plus 5, differentiates to 0. So we're done. So there's the answer to the first part. Okay, now we're asked to find when the curve, is it the same curve? Yes, it is the same curve. Just in case there's a trick in the question, it is the same curve that we've just found the gradient function for. We've been asked to work out the range of x for which the curve has a negative gradient. So when is this guy negative, is the question. When is this guy below 0? We've almost got to treat this like a separate question. This is a quadratic. It will be a U-shaped quadratic, something like that. Without working it out, I don't know where these points are, but you can see my example here crosses the x-axis at 2 points. So it is between these 2 points that the curve sinks below the sea level of the x-axis. So if we can find these points, we can then say, oh, well, the curve will have a negative gradient between these 2 goalposts. So if we factorize the quadratic, we will find these points, and we can then determine where the curve has a negative gradient. What's special about those 2 points is that the gradient function itself is 0. So if I set this guy to 0, find out the values of x, we're home and dry. Okay. We could use the quadratic formula, but let's just try working it out for ourselves. 3x should go here, x should go here. Now, 15 is 3 times 5. If I put a 3 here and a 5 there, what do I get? This will be 3x, this will be 15, and no way am I going to produce 4. So let's just try it the other way around. A 5 here and a 3 here. This will give us 9x, and this will give us 5. And yes, if I subtract the 5 from the 9, I will get a 4. Clearly, the 9 has got to be negative, so this guy is negative, and this guy is positive. Let's just check. There's our 3x squared. There's our negative 15. Here's our positive 5x, and here's our negative 9x. Positive 5x, take away 9x, is negative 4. Now, the logic bit. If this statement is true, either this term is 0 or this term is 0. X will be equal to negative 5 over 3, or x will be equal to positive 3. So the diagram wasn't entirely wrong. This turns out to be x equals 3, and this point turns into x is equal to negative 5 over 3. So we just need to write down the range of values for x where c has a negative gradient. So the goalposts themselves would have the gradient function as 0 gradient. So we need to be inside the goalposts. So when we write our inequality expression, we must exclude the goalposts. So x is going to be between 3 and negative 5 over 3. So to exclude the goalpost of x equals 3, we must write less than 3 and not less than or equals to 3. And equally here, to exclude the x is equal to negative 5 over 3 goalpost, another less than or equal sign. So finishing off, the gradient of c is negative when this inequality applies. And that is your answer.